Okay, we're working on the final exam study guide for college algebra, and I'm starting with number 28 on your study guide. It's y equals square root of 2 plus x. So it asks you to find the domain and the range. I think a sketch of that helps you determine the domain and the range. So you might know this graph. The y equals the square root of x function. Looks like a little arc. And then we're using our shifting rules here. The shifting rules are a very valuable thing to know. The shifting rules tell us if you have a number that is grouped with the x, whether it's in the radical with it or in a grouping symbol of any type, absolute values, parentheses, grouped in the denominator with it, anyway grouped with the x, with the action of the x, it's a left-right horizontal shift. So we are shifting this graph horizontally. And we do the opposite sign of what it looks like. It looks like a positive 2, so we're shifting it negative 2, back 2. So the graph would look like this. The arc graph shifted back 2 places. So the domain would be the left-right amount, the domain, the x values, or the left-right values, start at negative 2 and then go to infinity. Now we do want to use a bracket around negative 2 because it's including the endpoint at negative 2, and then infinity going to the right, positive infinity, infinities always have parentheses. The range would be the y values or the low to high values. On this graph, it's a low point or a y value of 0 at negative 2. It's negative 2, 0 for y. So 0, and then it's going upward, slowly upward, but it is merging upward without bound. So the y values or the range values is 0 to infinity, like so. Okay, number 29. We're going to talk about linear equations, linear graphs. It says find the graph and multiple choice graph that goes through the point negative 2, negative 6, and has a slope of 5. So this, you visually just want to use the practice graph that's on it, draw on it, and then find the one that matches it. So on the practice graph, you want to find the point, negative 2, negative 6. So back 2 and down 1, 2, 3, 4, 5, 6 places. Then the slope is 5. You could assume that to be over 1. So that's a rise over run. So you'll rise 5 and run 1 from the known point on your graph. So up 5, run 1, right 1, connect your dots, pick the graph that looks like that. Okay, number 30 says find the average rate of change. Average rate of change is another way of saying slope. That's how much your graph changes over time. The average rate of its change is its slope. So we have a graph. It's got various points dotted in, but the two that are most obvious is this point 0, 0, and then there's a point that's over 5 places, and then it's up, looks like 25. So 5, and then you read over here, looks like it's the point 5, 25. Or you could just kind of count how much does it rise to run, that visual or way that you could figure out slope. How much does this go up to over? It goes up 25 and over 5. That's one way to determine it. So the slope of that graph is 5. Or you could actually do the formula for slope is the subtraction of the y values over subtraction of the x values, and you could use these 2 points to subtract the y's over subtract the x. That would also give you the 5. So again, the key to that was knowing that rate of change means find the slope. Okay, number 31, still talking about lines. It tells us we have a line with a slope of negative 3/5 that goes through a point 7, 6. So we have a few equations to be familiar with of lines. We have the y equals mx plus b equation. That's when you have a slope, stands for slope, and y-intercept. We use that a lot when we're graphing, the slope-intercept method for graphing. We also have a formula y minus y sub 1 equals x minus x sub 1. We use this equation for what we're going to do here. It's the point, x sub 1, y sub 1 is a point on your line. And of course, is that slope again. So it's the point slope form of the equation. So we're going to input this slope in for m and this point that's known in for the x sub 1, y sub 1 to get the equation. But while we're at it, the other equation of a line you need to know is ax plus by equals c. That's considered standard form of a line. So if the directions say write it in standard form, that means no fractions can be in the answer or decimals. It's in integer format, and the x is in front, then the y, then the constant on the end of standard form. All right, so on this one, like I said, we're going to use this point slope form given here. So y minus the y coordinate is 6, the m negative 3/5, x minus the x coordinate is 7. So we input that information, and then we'll need to put it in the form it's asked. This one said to put it in slope-intercept form, so that means solve it for y. You could go ahead and distribute that fraction. I think that leads to a lot of mistakes, so I usually, my method would be clear the fraction before I do any form. So I'll times by 5 on either side, or each side, to clear the fraction. Here the 5 distributes, and the reason I times by 5 is so it would cancel out that fraction diagonally, and then I'm distributing just the negative 3. And then it's just easier for me then to work with for whichever form is asked. Since it said to put it in slope-intercept form, that means I'm solving for y, so I bring the 30 across the line, getting y, the y term alone. Then I need to divide by 5. So y equals negative 3/5 x, and then 51/5 at the end. So that's the slope-intercept form of the line. Okay, the next problem, number 32. Continuing with that idea, only taking it a step further, the clue for the slope, instead of just straight up saying, here's the slope is negative 3/5, they make us work for our slope. They give us a clue for the slope. They say we have a line that is perpendicular to 7x plus 4y equals 69. So that's a clue to the slope. We have to find our own slope, solve this for y, and then do the negative reciprocal of that slope of that line to get the slope. So again, just working for our slope instead of it flat out given. And then it tells me it goes through a point 7, negative 5. So it's going to be the point slope form of the equation again. Like I said, I don't know my slope. I have to work for it. So to find the slope that's needed, I take this line, 7x plus 4y equals 69, and I throw the x across the line, solve this for the y variable to get it in y equals mx plus b form, right? Y equals, there's the slope, mx plus b form. So there's the slope of that line. The slope of my line, if it were parallel, I'd use that same slope, but it's perpendicular. So perpendicular slopes are negative reciprocals slopes. So I need to flip that and make it a positive. Change its sign and flip. So the slope I need, the slope of my line that I had to use this clue for, is 4/7. So now I have my point, 7, negative 5, and my slope, and now I'm ready to put it into my equation. That equation again looks like this. So I plug in my y value, negative 5, my m value I found to be 4/7, my x value 7. Now, like on the last problem, like I told you, I prefer to clear the fraction regardless of what form I'm putting it in, so I'll times through by this 7 on each side. Also note a minus minus, I can make that plus. So I'll times each side by 7. 7 distributes to this side. On this side, the 7's cancel, then distributing the 4. All right, the directions then tell me what form we need this in. It says to write it in slope-intercept form again. So that means solve for y. So the 35 will cross over. Negative 28 and negative 35 will be negative 63. Then dividing by 7. There's our 4/7 in front of our x, we knew that slope. And then negative 63 over 7 is negative 9. So slope-intercept form of our line described. Okay, number 33, again, working on the linear equations. So, and then we'll shift gears to another topic. But number 33 is also linear. So all of this came from section 2.3 and 2.4. If you look that up in your book, that's what the sections would be for linear equations. All right, so number 33 is actually a reading problem, so let me read that to you real quick. It says, write the linear equation that describes this situation in slope-intercept form again. It says a company can make 11 airplane engines for $59,200. 27 airplane engines cost $68,800. So find the linear equation that models this. It does tell us to let X equal the airplane engines, so X stands for engines, and then we can make these like XY points. So 11 engines, $59,200. Think of that as an XY point. And then 27 engines, $68,800. XY point. So just think of those as XY values describing this situation. And it says it will be a linear situation. So this is similar to the last problem as well. We've got, this would be a clue for the slope. Again, you've got to find m. M equals, we can find the slope of a line by the slope formula that lets us subtract the y's over subtract the x's. I would use this method if I had 2 points on a line. If I had, like the last problem, I had the equation, so I used a different strategy solving for y to find y equals mx plus b. But this one, a little different. We know 2 points on the line, so we need this formula for slope. This is the formula you use when you have 2 given points. You subtract the y values, 68,800 minus 59,200, over subtract the x values in the same direction. If I want this minus this, I need to go to 27 minus 11. And then do that arithmetic. My calculator again. All right, 68,800 minus 59,200 equals 9,600. And then 27 minus 11 is 16. I wonder if that comes out even. I'm going to try dividing it. It does. So this all reduces to just the number 600. So the slope that describes this situation is it's a rate of change of 600 per engine. So I'm going to plug that information into my formula, the point slope formula we mentioned earlier. And I have 2 points. It does not matter which point you use, this formula comes out the same when you reduce it to standard form. So, so anyway, use which point you feel like. I'm going to use the first one for my x sub 1, y sub 1 point, and then my slope is 600. All right, so filling this in, y minus the y coordinate 59,200 equals m 600, x minus my x value 11. Once again, this one said to put it in slope-intercept form, so that means solve it for y. There is no fraction to clear this time. That's good news. I do need to distribute the 600. Then throw the 59,200 across. Let's see. Plus 59,200. Let's see what that gives me. Negative 52,600 for your final answer in slope-intercept form. And that is answer D in your study. Okay, let's go ahead and stop it there since that's the end of the linear.